Welcome to the lesson on constructions of triangles. At the end of this lesson, you will be able to construct triangles given its base, a base angle, and the sum of the other two sides. Its base, a base angle, and the difference of the other two sides. Its perimeter and its two base angles. The construction of an angle bisector, a perpendicular bisector, and angles are some of the basic constructions used for constructing geometrical figures. With the help of these, we'll learn to construct some triangles. Let's start with the first construction. Here, we'll construct a triangle where the base, one base angle, and the sum of the other two sides are given. Let's construct triangle PQR, where the base QR is equal to 5 centimeters. Angle PQR is equal to 60 degrees, and the sum of its sides, PQ and PR, is equal to 8 centimeters. Here's how it's done. First, draw a line segment QR of length 5 centimeters. Draw a ray QX inclined to the base QR equal to the given angle PQR, which is equal to 60 degrees. Take the measure of 8 centimeters and mark an arc S on the ray QX. This is the combined length of the sides PQ and PR. Join RS. Draw the perpendicular bisector of RS such that it intersects QS at P. Finally, we join PR. Thus, PQR is the required triangle. Now, let's verify if the triangle obtained is the required triangle. In the figure, side PR is equal to side PS. Since any point on the perpendicular bisector is equidistant from the endpoints of the line segment. Now, PQ is equal to QS minus PS. This implies PQ is equal to QS minus PR, or PQ plus PR is equal to QS. Thus, in triangle PQR, QR is equal to 5 centimeters. Angle PQR is equal to 60 degrees, and the sum of the sides PQ and PR is equal to 8 centimeters. Hence, verified. Let's now proceed on to the second construction. Here, we have to construct a triangle when the base, one base angle, and the difference of the other two sides is given. Suppose in triangle ABC, we are given the base BC, base angle B, and the difference of the other two sides AB and AC. Please note that there will be two cases of constructions. In the first case, AB may be greater than AC, and in the second case, AB may be shorter than AC. Let's construct the triangle when AB is greater than AC using the given data. To begin with, draw the base BC with a length of 5.5 centimeters. At point B, make an angle XBC equal to 40 degrees. Taking point B as the center, cut an arc with a radius of 2 centimeters on ray BX at point D. BD is equal to the difference of the given sides. Join DC. Draw a perpendicular bisector of the line segment CD such that it intersects the ray BX at point A. Join points A and C. Thus, ABC is the required triangle. We shall now verify whether the triangle we have drawn is the required triangle or not. AD is equal to AC, since point A lies on the perpendicular bisector of CD. Therefore, BD is equal to AB minus AC. The constructed triangle ABC is the required triangle. Let's now construct a triangle of the second case with the given data. Here in triangle ABC, side AB is less than AC. The first step is exactly the same as it was in the first case. Draw the base BC with a length of 5.5 centimeters. At point B, make an angle XBC equal to 40 degrees. Extend ray BX in the opposite direction. Mark an arc with a radius of 2 centimeters on the extended ray BX at a point D. BD is equal to the difference of the given sides. Join DC. Draw a perpendicular bisector of the line segment CD such that it intersects the ray BX at point A. Join the points A and C. Thus ABC is the required triangle. Now let's verify it. In this case, AD is equal to AC since point A lies on the perpendicular bisector of CD. This implies BD is equal to AC minus AB. Thus the constructed triangle ABC is the required triangle. Lastly, we are going to construct a triangle where its perimeter and two base angles are given. Let ABC be the given triangle in which the sum of its three sides is equal to 15 centimeters and the measure of its two base angles B and C are 70 degrees and 40 degrees respectively. Let's start with the construction. First, draw a line segment XY of 15 centimeters, which is equal to the perimeter of the triangle. Draw a ray XL at point X, making an angle of 70 degrees with XY. Similarly, draw a ray YM from point Y, making an angle of 40 degrees with XY. Now, draw the angle bisector of angle LXY. Similarly, we'll draw the angle bisector of angle MYX at angle Y such that it meets the angle bisector of the angle LXY at point A. Next, we'll draw the perpendicular bisector of AX such that it meets XY at point B. Similarly, we'll draw the perpendicular bisector of AY such that it meets XY at point C. Finally, we'll join AB and AC. Thus, triangle ABC is the required triangle. Now we shall verify whether the triangle obtained is the required one or not. B lies on the perpendicular bisector of AX. This implies XB is equal to AB. Also, C lies on the perpendicular bisector of AY. This implies YC is equal to AC. Now the perimeter of the triangle ABC is equal to the sum of its sides. But from equations 1 and 2, we can see that the sum of the three sides of triangle ABC is equal to XY. Now we'll show that angle B is equal to 70 degrees and angle C is equal to 40 degrees. Since angles opposite to equal sides of triangle are equal, this implies angle AXB is equal to angle XAB because side XB is equal to side AB. Now in triangle AXB, exterior angle ABC is equal to the sum of two interior opposite angles AXB and XAB. From equation 3, this is equal to twice angle AXB, which is equal to angle LXY. Thus, angle ABC is equal to angle LXY, which is equal to 70 degrees. Similarly, we have angle ACB is equal to angle MYX. Therefore, the triangle ABC is the required triangle.